Hi everybody. In this video, we will do some practice problems from section 4.4, where we have to do conversion, obversion, or contraposition, and determine the truth value of the statement following that, and write out the new statement. So the first here is no A are non-B. And it is given as true, and they want us to do the converse. So for conversion, for the converse, all you do is flip the subject and predicate classes, groups. Here, you might be tempted to say no B are non-A, but that is not correct. The entire predicate class here is non-B. So remember that whenever you're flipping a class, if it's everything outside of what B is or outside of what A is, you need to flip the entire class. So here it's actually no non-B are A. Now in conversion, if you just flip back a couple of pages, some of this is just going to be memorization, but you can also do the Venn diagrams to verify. But for converse statements, logically equivalent statements are E and I statements. So this is an E form statement, no SRP. So no A are non-B is the same as saying no non-B are A. And because they're logically equivalent, they always have the same truth value. So if the first statement were false, then the new statement would be false. But because it's true, the new statement is true. All right. Let's do some more. Okay, some A are B, and we are supposed to do the contrapositive of some A are B. When you perform contraposition, you flip the subject and predicate, and then you change the subject and predicate to their complements. So if you have A and B, the complement classes would be non-A and non-B. If you had non-A and non-B, then the complements would be A and B. So first we flip it, and then we change it to the class complement. So this would be some non-B are non-A. All right, now we need to determine the truth value. So in contraposition, and again, you can just go into your book, memorize these things. In contraposition, A and O statements are logically equivalent. E and I statements are not. So what we have here is an I statement because it's some SRP. So we have some non-B or non-A. Don't get non confused with not, as in the O statement. This is an I form statement. And so because they're not logically equivalent, we know that if that's true, then this is false. Wrong. That was a trick. If something is not logically equivalent, then we don't know what the truth value is. So some A or B could be true, and because they're not logically equivalent, depending on what the classes are in A and B, it could be the case that some non-B or non-A is true. It could be the case that that statement or proposition is false. So we say I, which means indeterminate, or you can say undetermined. But I like to use I, indeterminate. We don't know. We don't know what the truth value is. All right, let's continue. All right, I'm going to blow this one up a little so you can see it. The video might be a little bit difficult to see. Okay. All right, so next question. All A are non-B is given as false, and we're doing the obverse. Now, from the very beginning, you know that the obverse of every single categorical proposition is logically equivalent to its obverse, to its original. So what do you know automatically? Because if the first statement is false, what do you know automatically if we're doing obversion? You know that the new statement is going to be false of necessity. because every time you create an obverse, no matter what type, A, E, I, or O, it's always logically equivalent. So we know in the end this is going to be false. Now, for the obverse, it's again a two-part process. Converse is 1. Contrapositive is 1, 2. Well, 1 and then 2. And then the obverse is also a two-part process. What you do is you change quality while maintaining quantity, and you change the predicate class to its complement. All right, so what does it mean to change quality without quantity? That means that if you're working with universal statements, A and E, you change from positive to negative, or negative to, affirmative to negative, or negative to affirmative. So if this all A are non-B is what type of statement? It's an A-form statement, all SRP. So we need to hang out in the realm of the universal, the top of our square of opposition, and change the A form to an E form. So how do we do that? Well, if we were to just change this to an E form statement, it would be no A or non-B. So that is changing the quality of the statement without changing the quantity. But the thing about the obverse is that's only step 1. So step 1, change quality. Step 2 is you change the predicate to its class complement. So in this case, step 2 would be to change. So we already have no A or non-B. It would be technically to change it to no A or non-B. And we know logically non-non is the same as the affirmative. So we change non-B to B. So no A or B. All A are non-B. No A are B. And we know because they're logically equivalent that they are that statement must be false. All right, so just for giggles, let's do a little Venn diagram. So we have the classes here, A and B. A and B. Now, if we were to shade the first statement, all A are non-B. When we shade, remember, we create emptiness. So what the statement all A are non-B is saying is that there cannot exist an A that's a B. Well, if it's impossible for an A to be a B, then we need to shade in the middle. Remember that when you shade in a Venn diagram, you create emptiness. You're not shading where things are, you're shading where things are not. I like to think of it like in really extreme, like you're creating like a void, a total absolute nothing, right? So all A are non-B means all the A's that exist have to be outside the B circle. So therefore, we need to shade in the middle. All right, so we have this, right? All right, now let's do a Venn diagram for the second statement. This one's easier, right? Because it's one of our categorical forms, standard categorical forms. No A or B. Well, again, if this is saying it cannot be the case that there exists some A's that are B's. The A's that are B's live right in here, right? So if no A's that are B's live in here, then we need to shade because we need to create emptiness there. Notice the diagrams are exactly the same. And so when you have the same two circle Venn diagrams for different statements, you know that they're logically equivalent. Thus, if the first one is false, the second one of necessity must be false. Now, if this said that this were true, then this one would be true. We don't know the truth value of these statements because we don't know what the classes are. Like all dogs are non-reptiles. That would be a true statement. So if I said, let's just actually do this. All dogs are non-reptiles. That's true, right? A similar statement would be no, or the obverse of this statement would be no dogs are reptiles, which is also true. Sorry, I should have put my periods here. Now let's try one that's false with the same classes, or maybe not exactly the same. So all dogs are non-mammals. That's a false statement, right? The obverse of that statement would be no dogs are mammals, which is also false. And no matter what you put in there, this relation will always hold for the obverse. All right, let's try one more that's a little bit different here. All right. This one's a little bit different. In this one, you're given the two statements. You've performed some operation on them, either conversion, obversion, or contraposition. We don't know yet, and that's what we need to determine here. And then we need to determine the truth value of the new statement. Okay, so we know that the first statement is true, and it says some A are not non-B. Now remember what I said earlier, don't get your nots and your nons mixed up. Because really what the first statement is saying is some S are not P, where non-B is in the place of P. So really this is an O form statement, right? So we've identified the statement. All right, now, so we have some A are not non-B. We know that's an O form statement. And now we need to figure out how to get some ARB from that. Now you should recognize right away that we haven't flipped the subject and predicate classes. And remember, two of the three forms here require that we flip subjects and predicates. So what is the only option? Obversion, right? Now, it could be the case, though, that they're playing a trick on us and it's nothing. I don't know if that's an option here, but it would make the activity more fun, right? Because it could be that they're just messing with us and they're not doing anything properly. So we need to make sure that this is the obverse. All right, so in obversion, or in the obverse, what we do is we maintain the same quantity. So if we're working in a universal, we maintain A or E. If we're working with the particular, we maintain I or O. So it looks like we've maintained the particular quantity. So that's a good hint that it's obversion, that it's the obverse. And then the second thing we do is we change the predicate, we've maintained the quantity. The second thing we need to do is change the quality. So as I said before, we know the first statement is some S are not P. And so to change the quality, we need to change that to the affirmative statement, which is some S are P. All right, so that's step two. First, maintain quantity. Second, change quality. And third, change the predicate class to its class complement. So the class complement, so we have our first, the predicate class in the first statement is non-B. So the class complement is B. The class complement of everything that's not B is B. The class complement of everything that's not a human is a human. The class complement of everything that's human is everything that's non-human, including rocks and chairs and air and everything that even doesn't exist, like unicorns. I hope they exist somewhere. But anyway, apart from that. All right, so, and that's precisely what we have here. We see that we've changed the quality from an O statement to an I statement, and we've changed the predicate class to its complement. So some ARB, so we know that we've used that these are obverses of one another, and we know that the statement must be true, because remember, every time that you have the obverse of a categorical proposition, they have the exact same truth value because they're logically equivalent. All right, that was the longer explanation video, and I'm gonna create another video where I just knock out some more problems so that we can do some more practice.